Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have the second lesson in the trigonometry. And the trigonometry, as we studied in the first lesson, is the branch of mathematics that studies angles and sides of a triangle. But in this section, we are going to study only the right angle triangle as we studied in the first lesson, and we are going to continue in the second lesson. Today, inshallah, we have unit 4, lesson 2. The lesson is called the main trigonometrical ratios of some angles. I said here of some angles because we have only 3 angles, 30, 60 and 45, and we have some special angles in the next year, inshallah. And the rest of the angles we are going to study by using calculator, but now I'm going to explain some special angles. How can we identify the sine, cosine and the tan of the 3 angles? Okay, let's start the lesson. Now we have special right angled triangles. I have to remember two special right angled triangles. The first one we have studied in the second prep is called 30-60 triangle. From its name, its triangle included 30-degree angle and 60-degree angle, and the third angle is right angle like this. Okay, now by looking to the 3 angles, we have 90, 30 and 60 here. Okay, we remember that the side which opposite to the 30-degree angle equal half the length of the hypotenuse. For example, if the side opposite to 30 equal 1 centimeter, then the hypotenuse equal 2. If the side here equal 5, the hypotenuse equal 10. If the side here equal 10, then the hypotenuse equal 20 and so on. Okay, now let this side equal 1 and the hypotenuse equal 2. So the third side, by using the Pythagorean theorem, equal square root 2 power of 2 minus 1 power of 2 equal root 3. Okay, now by using the 3 sides 1, 2 and root 3, we can guess the 3 ratios of angle 30. Number 1, but before explaining this one, don't forget so ka toa again. So ka toa, sine opposite hypotenuse, cosine adjacent hypotenuse, tan opposite adjacent. Okay, now sine 30 equal opposite over hypotenuse equals 1 over 2, and cosine 30 equal adjacent over hypotenuse root 3 over 2, tan 30 equal opposite over adjacent equal 1 over root 3. Okay, now angle 60. In the angle 60, root 3 is the opposite, 1 is the adjacent, 2 is the hypotenuse. Again, opposite, adjacent, hypotenuse. Okay, sine 60 equal opposite over hypotenuse equal root 3 over 2. Cosine 30 equal adjacent over hypotenuse equal 1 over 2. Tan 60 equal opposite over adjacent root 3 over 1 or root 3, because root 3 over 1 equals root 3. Now I'm going to study the second special triangle, which is isosceles right triangle or right isosceles triangle. This one is a right angle triangle in which its vertex angle is right it will be like this. This is isosceles triangle. Then the two other angles will be 45 and 45. Okay, and here we have the two legs are equal. This is isosceles and right triangle. Okay, let the two legs equal 1 and 1 like this. Then the hypotenuse in this case equal square root 1 power of 2 plus 1 power of 2 equals square root 2. So by using this triangle, I can guess the angle, the trigonometrical ratios of angle 45. For example, sine 45. Sine 45, this is the opposite equal 1 and the adjacent also equal 1. The hypotenuse equal root 2. Then the sine of 45 equal opposite over hypotenuse 1 over root 2. Adjacent of 45, cosine 45 equal adjacent over hypotenuse equals 1 over root 2. Tan 45 equals 1 over 1 equals 1. Now, by this way, we can deduce the trigonometrical ratios for 30, 60, and 45 degree angles. Okay. Now, I'm going to solve problems about this concept. In this example, complete the following. Cosine 30, sine 30 plus cosine 60 minus tan 45. Okay. It will be sine 30 equals half plus cosine 60 equals half minus tan 45, which is 1. It's equal half plus half, 1 minus 1 equals 0. Number 2. Here we have number 2. Tan squared 60 plus cosine 60 minus tan 45. Okay, tan squared 60 equals tan 60 equals the square root 3 all power of 2. This is tan square 60 plus cosine 60, which is equal 1 over 2 minus tan 45, which is 1. It's equal root 3 power of 2 equals 3 plus half equals 3.5 minus 1 equal 2.5. The next one, sine 30 cosine 60 equals sine 30 equals half times cosine 60 equal also half plus sine squared 60 equals root 3 over 2 all power of 2. Finally, this one equals 1. Okay, the next example. Without using calculator, prove that number 1, sine 60 equals 2 sine 30 cosine 30. Okay, number 1, I'm going to start with the left hand side. The left hand side equal sine 60, sine 60 equal root 3 over 2. Okay, now the right hand side. The right hand side equals 2 times sine 30, which is 1 over 2, times cosine 30, which is root 3 over 2, 2 cancelled with 2, finally it's equals root 3 over 2. Therefore the left hand side equals to the right hand side. The next one, here we have square root tan 60 equal the left hand side equals tan 60, which is square root 3, and the right hand side equals fraction 2 times 1 over root 3 over 1 minus open brackets 1 over root 3. Finally this one equal root 3. Therefore the left hand side equal to the right hand side. Number 3, start with the left hand side. The left hand side here equal cosine square 60, which is cosine 60 equals 1 over 2, all power of 2 equals 1 over 4. The right hand side equals open brackets 5 open brackets sine square 30, which is 1 over 2, all power of 2, minus tan squared 45 minus 1, all power of 2, equals 1 over 4. Therefore the left hand side equal to the right hand side. Now we have example 3. In this example, find the value of x. Number 1, find the value of x where x equal x root sine 30 cosine square 45 equal cosine square 30. This is an equation. Okay, then I will write x times sine 30, which is half, times cosine square 45, which is cosine 45 1 over square root 2, all power of 2. This one equal cosine 30, which is root 3 over 2, all power of 2. Okay, therefore x times 1 over 2 times 1 over root 2 all power of 2 equals 1 over 4 equals 3 over 4. Okay, now I can cancel 4 with 4, or I can send 1 over 4 there to be divided. Therefore x equals 3 over 4 divided 1 over 4. Therefore x equals 3. Don't forget, I send 1 over 4 there as a divide. Therefore x equals 3. Number 2, 4x cosine square 30 tan squared 30 tan squared 45. Okay, it will be 4x equal cosine square 30, which is root 3 over 2 all power of 2 times tan square 31 over root 3 all power of 2 times 1 all power of 2. Then for x equals 1 over 4, I will send 4 there as a divide. Therefore x equals 1 over 4 divided by 4. Therefore x equals 1 over 16. Okay, now let's study some important remarks. Okay, now because the remark is very important, then I will reback the special angles as we studied before. Okay, by looking to sine 30 and cosine 60, we observe what? We observe that sine 30 equal half and cosine 60 equal half. That's because 30 plus 60 equals 90. Another remark, cosine 30 equal root 3 over 2 and the sine 60 also equal root 3 over 2. That's because 30 plus 60 equals 90. Another example, sine 45 equal 1 over root 2, cosine 45 equal 1 over root 2 because 45 plus 45 are equal. So the sine and the cosine are equal if the sum of the angles equals 90 degrees, like 30 and 60, like 45 and 45. Then the remark will be like this: if sine x equal cosine y, then x and y, their sum equal 90 degrees. Don't forget, if the sum equal 90, then the two angles called complementary. Called complementary angles. So then the sine and the cosine of two complementary angles are equal, and this is explained by numbers here. Okay, now another remark here, by looking to the 30-degree angle. Here sine 30 equal 1 over 2 and the cosine 30 equal root 3 over 2. What if we divided half divided root 3 over 2? It equals 1 over root 3. So tan 30 equals sine 30 over cosine 30. Another example, if we divided sine 60 by cosine 60, root 3 over 2 divided 1 over 2, it gives me root 3. Then sine 60 over cosine 60 equal tan 60. Also 1 over root 2 divided 1 over root 2 equal 1. So sine 45 over cosine 45 equal tan 45. So tan x equals sine x over cosine x. This is another rule for tan. Tan equal opposite over adjacent, or tan equal sine over cosine. For example, tan 60 equal sine 60 over cosine 60. You can check by the calculator. Or tan 30 equal sine 30 over cosine 30. Also you can check by calculator. And tan 45 equal sine 45 over cosine 45. Okay, another remarks. Also by using the same angles or the same special angles, here by looking to this equation, sine x equal half, this is an equation. If he gave me in the question sine x equal half or cosine x equal or tan x equal, then you have two ways. The first way, that you are going to search which angle its sine equal half. I'm going to search in the sine which angle its sine equal half, this angle. Sine 30 equal half, then x here equal 30. Okay, but if we have also root 3 over 2, okay, sine what equal root 3 over 2? Sine 60. Then x here equal 60. But if he give me unknown angle 0.3, unknown number 0.3, there isn't any number here equal 0.3. So I will do what? I will use the calculator like this. I will switch sign into the other side to be sine power -1, or it called arc sine. Okay, arc sine 0.3. Okay, by using the calculator like this, okay, how can I write arc sine or switch the sign in the calculator? Shift sine, it written like this, sine -1. Then I will write 0.3, close the bracket, equal. Then the angle will be 17.45 and so on. Because this number is an angle, so it's better to change into degree minute second like this. 17 degrees 27 minutes 27.35 seconds. So if we have sine angle and we need to find the angle, we can find the angle by two different ways. If the number given of the sine or the cosine is a special number, then you can use the angles, okay, you have studied. But if we have a number except them, then you can use calculator. You make shift sine or shift cosine or shift tan. Okay, the angle here will equal 17 degrees 27 minutes 27.37 seconds. Okay, complete the following. Number 1. For any two acute angles A and B, if sine A equal cosine B, that means A and B together equals 90 degrees. Then measure A and B equals 90 degrees. Number 2. Measure of angle A equals 75 and B sine B equal cosine A. Also A and B equals 90 degrees. Then measure of angle B equals 90 minus 75 equals 15 degrees. In triangle ABC, measure of angle A equals 60 and sine C equal cosine C. Sine C equal cosine C. Here the two angles equal 90 degrees. Then 2C equals 90. That happen when C equal 45 degrees. Again, 2C equals 90. Therefore, C equals 45 degrees. Okay, here we have a triangle like this. A, B, and C. Angle A equals 60, B equal is unknown, C equals 45 degrees. Then measure of angle B equal what? 180 minus open bracket 60 plus 45 equals 75 degrees. Number 4. Sine 30 equal cosine what? Sine and cosine are equal when the sum equals 90. So 90 minus 30 equal 60 degrees. Number 5. In triangle ABC is right at angle B and isosceles, then tan A equal what? Here we have isosceles and right triangle like this. I have explained the isosceles right triangle. Its angles equal 45 and the other angle also equal 45. Okay, right angle triangle at B, and here A and here C. A equal 45, C equal 45. Then tan A equal tan 45 equals 1. Example 5. In the example sine x equal 30, tan 30, sine 60, where x is a measure of an acute angle. Okay, then find without using calculator 4 cosine x tan x. First I need to find sine, to find x. Okay, sine x, excuse me, sine x equals tan 30, which is 1 over root 3, times root 3 over 2 over 2, that equal half. Okay, sine x equal half. You have two ways. Sine what equal half? Sine 30. Or you make arc sine, shift sine half, it gives you 30. Then x equals 30 degrees. This is x. But here he asked about 4x sine 2x, tan 2x, therefore 4 cosine 30 tan 2 times 30 equals 60, tan 60 equal 4 times root 3 over 2 times square root 3 equal 6. Example 6. In this example, ABC is an isosceles triangle. Okay, AB equal AC equal 7 centimeters and BC equal 10 centimeters. Okay, first I need to draw the triangle, the isosceles triangle, like this. Okay, now we have isosceles triangle, as you see, where AB equals AC equals 7 centimeters and BC equal 10 centimeters. I can't solve in trigonometry using this triangle, so I will do triangle in two right angle triangles like this. I will draw the height from A like this. For example, I will call this one D. Okay, in the second prep, we studied the axis of symmetry of the isosceles triangle. The axis of symmetry of the isosceles triangle, line drawn from the vertex perpendicular to the base. This line do what? This line bisect the base and bisect the vertex angle. Okay, now the base equals 10, then it bisect the base to be 5 and 5. Then CD equals 5, BD equal also 5. Okay, now I need to find the measure of angle B. Measure of angle B. Okay, in triangle ABD, I choose here right angle triangle ABD. Okay, this triangle B, angle B, we have 5, which is adjacent to 5, and we have 7, which is the hypotenuse. Adjacent and the hypotenuse is the cosine of angle B. Okay, then cosine B equal 5 over 7. Why do I find the cosine? Because I need the sine, cosine or tan to find the angle to make shift tan. Okay, so measure of angle B equal shift cosine or arc cosine 5 over 7, which is equal 44 degrees 24 minutes and 55 seconds. Okay, this is measure of angle B. Okay, now I need the area of triangle ABC. All of us know that the area of triangle equal half times the base times the height. Okay, to find the area of triangle ABC, I need to find the height. The height here, AD, equals square root 7 power of 2, hypotenuse power of 2, minus side power of 2, 5 power of 2. It's equal 2 square root 6. So the height equal 2 square root 6. Therefore, area of triangle ABC equals half times base times height equals 10 square root 6 centimeter square. Example 7. In this example, ABCD is a rectangle in which AB equal 15 and AC equal 25. Find the measure of angle ACB. Okay, number 1, measure of angle ACB. Angle ACB exists in triangle ABC, which is right angled triangle. Okay, here to find the angle we need sine, cosine or tan. I have the opposite and the hypotenuse, so I have the sine of the angle, then measure of angle ACB equal shift sine 15 over 25. Don't forget to use the calculator like this. Shift sine 15 over 25 equal 36.8, but I will write the angle with degree minute second, equal 36 degrees 52 minutes 11.63 seconds. This one can written as 11.63 or approximate 11 to be 12. Okay, I will write it like 36 degrees 52 minutes and 11 seconds or 12 seconds. Both are correct. Okay, number 2, find the area of the rectangle. To find the area of the rectangles, then we need the length of BC. BC equals square root 25 to the power of 2 minus 15 power of 2 equals 20. Therefore, area of triangle, of ABCD rectangle equals length times width equals 20 times 15 equals 300. Example 8. In this example, we have here ABCD is a parallelogram whose area equals 96 centimeters squared. BE to EC equals 1 to 3, and I'm going to explain later what does it mean. AE to BC equal perpendicular. AE equal 8 centimeters. The first required, find the length of AD. Okay, find the length of AD. To find the length of AD, number one, AD here is the base of the parallelogram. By using the area of the parallelogram equal base times height. Here we have the area equals 96, the height equals 8. So the base AD equals area divided height equals 96 divided by 8 equals 12 centimeters. So AD equals 12. Also BC equal 12 centimeters. Now back to this ratio. What does it mean? BE equal 1 unit and EC equals 3 units. Now since BC equals 12 centimeters, so I will divide 12 by 4 units. So BE 12 divided by 4, 3, and EC equals 3 times 3 equals 9. So BE equals 3 and EC equal 9. I can solve this one by another way, by the ratio 1 to 3 to sum, which is 4, and here I write 12. 1 times 12 over 4 equals 3. 3 times 12 over 4 equals 9. Now I solved this one by two different ways, but I prefer the way of the units. Okay. Then BE equal 3 centimeters. As I said, required number 2, measure of angle B. Find the measure of angle B. Okay, B number 2 in triangle ABE, because this is the right angle triangle. B included the opposite and the adjacent. The opposite and adjacent, this is the tan of the angle. Measure of angle B equals shift tan 8/3, which is equal 69 degrees 26 minutes and 38 seconds. This is measure of angle B. The third required, find the length of AB to the nearest 1 decimal place. Okay, number 3. Now I need to find AB. I can find AB by two different ways. I can find AB by using the sine or cosine, or because I have already angle B, or I can find by Pythagorean. It's easy to use Pythagorean theorem. AB equals square root 8 to the power of 2 plus 3 power of 2. It's equal 8.54 approximately. To the nearest 1 decimal, underline the first 1 decimal, look to the next. 4 here is weak, so I will write 5 without adding 1. It will be 8.5. This is to the nearest 1 decimal. Okay, the next example, example 9. Here in this example, find the length of the marked sign in each of the following figures to the nearest 2 decimal digits. Okay, in the first one, the required here is BC. Okay, here we have angle C equal 32. We have 6 is the opposite. BC, or the required, is the adjacent. What is the relation between the opposite and the adjacent? It's the tan. So 10 32 equal 6 over, I will call the required here x. So it will be x, 6 over x. Okay, now by putting here over 1, so x equals 6 times 1 over 10, 32. X equal 6 times 1 over 10, 32. It's equal 9.602. To the nearest two decimal place, underline the second two decimal. Looking to the next is weak, so I can't add 1 to 0. It will be 9.60 without change. Okay, or I can write it 9.6. Number 2. Here the required is AB. I call AB x. Okay, what is the relation between angle A and 8 and x? Angle A, x is the adjacent, 8 is the hypotenuse. Adjacent and the hypotenuse, this is cosine. So cosine 50 equals x over 8. Okay, I will send 8 there as a time without cross multiplication. Then x equals 8 times cosine 50. By using the cross multiplication, we will put here 1. It will be 8 times cosine 50 over 1. Both are correct. Okay, it will be 5.1 4 2 3. The second digit decimal place is 4. Look to the next is weak. The 2 here is weak, so it will be 5.14 without change and leave the next. Okay, number 3. Here angle C is the required. We have its opposite and its adjacent. Okay, opposite and adjacent, it's 10. So 10 C equals 10 over 6. So to find C, I will make shift 10, then C equal shift 10, 10 over 6, which is equal 59.0362, approximately to the nearest second two digits. Look to the third one. 6 is strong, so we add 1 to the 3, 59.04. Here he asked me to the nearest two decimal, so he need it by decimal, not by degree, minute, second. Example 10. Choose the correct answer. 2 sine x equal sine 60. Then x equal what? Okay, now I will send 2 there as a divide. Tan 60 equals root 3. Then sine x equals root 3 over 2. Which angle its sine is root 3 over 2? It's 60 degrees. The next one. Tan 3x equals root 3. Okay, where 3x is an acute angle, then measure of angle x equal what? Okay, first, which angle its tan equal root 3? It's 30 degrees. Then 3x equals 30. If you don't remember, make shift 10 root 3. Okay, so I will send 3 there because he asked me about x, not 3x. 3 there by divide, then x equals 30 divided by 3, then x equal 10. Number 3, cosine x over 2 equal half, and x over 2 is an acute angle. Find the measure of angle x. Okay, here the angle is x over 2. Again, the angle is x over 2, not x. So don't cancel 2 with 2. It's a very big mistake. Okay, so I will search about angle, its cosine is half. Again, I will search about angle, its cosine is half. Okay, which angle its cosine is half? This angle is 60. Okay, then x over 2 equal 60 degrees. Now I need x, so I will send 2 as time. Therefore, x equals 60 times 2 equals 120. Okay, this is measure of angle x. Number 4, tan 75 equals what? Tan 75, as we said before, equals sine 75 over cosine 75. And this is the end of the lesson. I hope it was helpful for you. See you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.